Hello, my name is Sonali and I am here the assistant professor in the AKGEC Engineering College. Today's my topic is the concurrency and its base protocol. Now, first, I want to discuss what is the concurrency. Concurrency is the ability of a database to allow multiple transactions running in the data server at the same time. But with the when we try to execute the number of transactions at a time, there are some problem occurs, and there are the three problems due to the concurrency. First one is the lost update problem, second one is the dirty read, and third one is the incorrect retrieval problem. Now we will discuss all these problems one by one. Now first of all we discuss what is the lost update problem. The lost update problem, it means that if two transactions, that is the T1 and T2, both read the same data and update it, then effect of the first data will be overwritten by the second update. We can also see that with the help of this example here. These are the two transactions T1 and T2, and both the transactions read the data here. T1 read the data X and T2 also read the data X, but T1 update this data before the T2, and after that T2 update this data. Now in both the conditions, the T2 update the data of X and it will be override the data of T1. That's why here is a problem that the lost update. Whatever the T1 update, the value of X is lost because T2 override this problem, that is the X50. Now first of all, suppose the value of X here is the 50. Now initially let's take the example, value of the X is 100. T1 read the value of X, that is the 100. After that T2 read this value, that is 100. Now T1 update this value. Now the value of X is 75. For T1 the value of X is 75, but again T2 update this value, it right is 50. Here there are two values of X, that is 75 and 50. It means that T2 override this value of X, that is 50. Now this is the problem of the loss update problem. How to avoid this? A transaction T2 must not update the data item X until and unless the transaction T1 can commit the data item X. These are two transactions. First T1 start and after that T2 start. Then T2 cannot update the value of X until and unless the T1 commit this transaction. So, but without committing the T1, T2 update that problem. That's why this problem occur. So if we want to remove this problem, then we first try to commit this T1 transaction, and only after that we can start the T2 transaction. Now the next problem is the dirty read problem. It means, as the name suggests, that the dirty read problem arises when one transaction update the some items and then fail due to the some reasons. Here T2 update the value of X. Initially the value of X is 100, but here we start from the T2 transaction and T2 update the value of X. Now the value of X is 50. At the same time, after a second or a minute, T1 read this value X, but in between this duration, the updated value of X is failed, is not updated due to some reasons. But here the T1 read the value of X, that is the 50, but this updated value is lost. That's why the T1 read the value of X, that is a lost value. That's why it is called the dirty read problem. T2 transactions failed in between these times. That's why during that time T1 read that value. It means T1 read the lost or the unupdated value. That's why this problem arises. So whenever this type of problem arises, then here from this point the T2 again roll back. Now this updated item is retrieved by another transaction before it is changed back to the original value. Now there is a solution of this problem. The transaction T1 must not read the same data item until and unless the transaction T2 can commit the data item X. Only by this solution we can avoid this dirty read problem. Now the third problem is that the incurrent retrieval problem. Now we start from here. What is the incurrent retrieval problem? The inconsistent retrieval problem arises when one transaction retrieves the data to use in some operation, but before it can use this data another transaction and update the data and commit. Through this change will be hidden from the first transaction and it will be continue to use the previous retrieved data. This problem is also known as the inconsistent analysis problem. And here I will explain this incurrent retrieval problem with the help of example. Initially the value of A is 200, value of B is 250 and C is 150. We start this process from the transaction T1. Initially T1 reads the value of A and that is the value of A is 200. Whatever the value of A, it comes assigned to the sum. Now the value of sum is 200. Again T1 reads the value of B at the time of T2 and the value of B is 250. Now we perform this operation, that is sum equals to 200 plus 250, that is 450. After this operation T2 start and T2 read the value of C and the value of C is 150. After that T2 update the value of C and this is the updation process. 150 minus 50, that is 100. Now this is the value of C. Now C is the 100. Again T2 read the value of A and the value of A is 200 initially, that is value of A is 200. Now T2 update the value of A, that is 200 plus 50, that is 250. Now the value of A is 250. Okay, and after performing these operations T2 commit. At the time of T7 T2 commit the process, but after this committed at the time of T8 T1 read the value of C and now the value of C is 100. Here is the problem of incurrent retrieval because T1 start before the T2 but T2 committed before the T1. Here T1 read the value of C is 100 but this is not the correct value of C because the correct value of C is 150 and this is the correct value of C for the T1, that is the 150, but it read the value of C, that is 100, that is updated by the another transaction, that is the T2. But when we use the process of the serial scheduling, always whatever whichever the which transaction is executed, executed the first, it committed the first, not the second one. But here the T2 transaction committed first before the transaction T1. So that's why the T1 reads the value of C, that is the incorrect. So this is the problem of the incurrent retrieval, and all this process is hidden from the T1 because it is already committed before the T1 committed. Now we can avoid this problem. A transaction T2 must not read or update the data item until and unless the T1 transaction commit the data item. We can avoid this incurrent retrieval problem by this solution. A T2 transaction must not read the data or update any value until and unless T1 perform the commit operation. Until and unless T1 perform the commit operation, T2 cannot perform any operation, either the read or the update. We can avoid this problem by this solution. Now whenever we use the concurrent transaction, there must be the number of problem arises, but we can solve these problems with the help of the lock. Now what is the lock? A lock is a variable associated with the data item to control the transaction concurrent transaction access to the same data item. It means when number of transactions executed simultaneously, we use the concept of lock. With the help of lock, we can lock a transaction and that transaction perform their operation until and unless it committed. Now Let's suppose we can explain with the help of this figure. This is a figure, and there are the 4 person or the 4 customers, and yeah, or we can say that these are the 4 transactions here, and this is the database. Locking is a strategy that is used to prevent such concurrent access of data. Here there are the 4 transactions, and the transaction 1, suppose this is a transaction 1, and transaction 1 accesses this database. It can whenever it accesses this database, it can either write or read or update the database. We don't know, but at the same time the another transaction enter, and it also want to access this database. But here we can lock this transaction 1 until and unless this transaction perform its committed operation. We cannot give the privileges to another transaction to access the resources of this database. Now this is the process of the lock. Now we here we can use the lock with the help of these 2 methods, that is the lock based protocols. We can lock our data in a 2 ways, that is called the shared mode or the exclusive mode. Here in shared mode we can take this lock, we can just read the item but cannot write. Whenever the transaction have this shared mode, it can only read the data item but cannot write. But in this second mode, that is the exclusive mode, whenever any transaction that enter into this mode, that transaction can read as well as the write that data item at the same time. Now we can also explain with the help of this matrix. Suppose this is the transaction T1 and this is the transaction T2. Whenever the transaction T1 has the share lock and the T2 also has the share lock, then both the transaction can do the read operation at the same time. It means it is compatible for the T1 and T2. But whenever the T1 has the exclusive lock, that is the write operation lock, and T2 also has the write operation lock, then it is not the compatible for the T1 and T2 transaction, because the 2 transaction cannot perform the same write operation on the same data item. Now another, when T2 transaction has the exclusive lock and T1 transaction has the share lock, we can also again cannot perform this. It is not also the not compatible, because at the same time 2 transactions cannot read or write the data write the same data item. Now again, whenever the T2 has the exclusive lock and T1 has the exclusive lock, again this is not compatible, because at the same time 2 transactions cannot perform the write operation on a same data item. So only from this figure we can also we can see that when both the transaction has the share lock, only and only it can they can perform the read operations. But if any of the transaction has the exclusive lock, then it cannot perform any write operation, any other operation. So it means we also know that we have the 3 confliction pair, that is the read write, write read, and the write write. These are the confliction pairs. It means that for the conflictions, at least one write operation must be there. And if any one of the write operation is there, then we can say that this is the confliction. And during the confliction, we cannot perform the write operations. Now again, this is the continue of the lock-based protocol. This locking technique or locking protocols divide the transaction execution phase into the 3 parts. These lock techniques are divided. These are the 3 parts, that is the 1, 2, and 3. In the first part, whenever the transaction starts the executing, create a list of data items on which they perform the need locks or request the system for the locks needs. In first part, whenever the transaction start its process, or we can say that it started executions, first of all it create a list of data item on which they want to lock and request the system to perform or to provide all the locks whatever it needs. In the second phase, whenever the transaction acquire all locks, no other locks is required. It means transactions keep executing its operation. Whenever the transaction acquire all the required locks, and at that point it doesn't need any other locks, It means that the transaction are ready to executing its operation. This is the third, that is when as soon as the transaction releases first lock, whenever any executing transaction start to release its first lock, then at that time it enter into the third phase. In this phase, a transaction cannot retrieve any lock but can release only the locks. In third phase, whenever the transaction start to release its locks, it enter into this phase, and in this phase it can only release the lock. In this phase it cannot get any lock. Now suppose this is a transaction, and this is the first phase, second phase, and the third phase. In first phase it acquire all the needed locks on the data items, and the second phase it starts, or we can say that it ready to get into the execution phase. And third one is called the releasing phase. Whenever the transaction start to release any one of the lock, it means it enter into the releasing phase. Now this is another protocol, that is the two-phase locking protocol. Previous that I discussed the lock based protocol, and now this is the two-phase locking protocol. In this we have two phase. The one phase is the growing phase, and second one is the shrinking phase. It is somehow is similar to the locking based protocol. In growing phase, whenever the transaction enter into the growing phase, it means it can obtain locks but cannot release any lock. In this phase, any transaction obtain any lock, any required lock, but it cannot release any lock. Whenever a transaction take the final lock is called the lock point. Whenever the transaction enter into the growing phase, and when it achieve the final lock, it means it is at the point of the lock point. Now the shrinking phase, in this phase a transaction can release lock but cannot obtain any lock. Both the phases are the opposite to each other. The transaction enter into the shrinking phase, it means it releases the first lock after the crossing the lock point. In first transactions we can only get the locks, or we can achieve the locks, and in this second phase we can only release the lock, but we cannot achieve the lock in this transaction in this phase. And whenever transaction enter in this phase, it means it achieving all the locks those are required, and whenever enter into this phase, it means it releases all the locks that are useless now for this. Now now again this is also a locking lock based protocol, that is the strict two-phase locking protocol versus the rigorous two-phase locking protocol. This is also the important one, strict and the rigorous. As these name also suggests that what is the strict and what is the rigorous two-phase locking protocol. In the first one, a transaction may release all the shared lock after the lock point. Lock point is that point whenever a transaction achieve all the required locks. In this phase, a transaction may release all the shared lock after the lock point has been reached, but it cannot release any of the exclusive lock until the transaction or aborts. Strict two-phase locking means here in this phase we can release all the shared lock, but we cannot release any of the exclusive locks until and unless the transaction enter into the commit state. It ensures that if data is being modified by one transaction, then other transaction cannot read it until and unless the first transaction commit. It can also ensure us to that it can modify if some suppose we have a transaction T1 and it can update a data item, that is A. That data item cannot be used by any other transaction until and unless this transaction enter into the commit phase. If we do this process with the help of this strict two-phase locking protocol, we can solve this problem, that is the dirty read problem. And this is the problem occurs whenever the number of transactions executing simultaneously, or we can say that parallelly. In this second rigorous two-phase locking protocol, in this protocol, a transaction is not allowed to release any lock. In this phase, we cannot release any of the locks, either the shared lock or the exclusive lock, until and unless it committed. This means that until the transaction commits, other transaction cannot require even a share lock or a on the data item on, and with uncommitted transaction has the share lock. In the rigorous lock-in protocol, we cannot release any of the locks, either the shared or the exclusive locks, until and unless that transaction come into the committed phase. Now this is again a protocol that is the concurrency based protocol, that is the timestamp based protocol, and this is the another step to control the concurrency process. This protocol use either the system time or the logical counter to be used as a timestamp. As the name suggests, that is a timestamp, so that's why this protocol use the system time or the logical counter for performing their operations. Every transaction has a timestamp associated with it. Every transaction, whatever the transaction involved in this protocol, has associated with the time, and ordering is determined by the age of the transaction. Suppose a transaction T1 is created at this time, would be the order then the other transaction which is come after it. Suppose we have the transaction T1 and it come at the 2 p.m. suppose, and the transaction T2 come after the 3 p.m. It means T1 is the older one and T2 is the younger one transaction. In addition, every data item is given the latest read and write timestamp. This let the system know which last read and write operation was made on the data item. In this process, every transaction associated with the data item and every data item like the A, B, C also associated the timestamp, so that we can easily recognize the last read or the last write operation whatever the perform on the data item. This is the responsibility of the protocol system, that the conflicting pair of tasks should be executed according to the timestamp. These are the three conditions. On this condition, we can perform this protocol. There are the three timestamps. First one is the timestamp of the transaction T1. Suppose we have a transaction T1 and a time associated with this is called the time of the timestamp of the T1. Second one is the read timestamp of the data item X is denoted by the write timestamp of it. Suppose a data item is A. We want to read this data item and we can write this like this. The data item A is read at the time. Suppose the time of this is the 1 p.m. or 2 p.m. like this. And the third one is the write timestamp of data item, and we can denote it like this. So in this protocol, we use only these three timestamps, and these are the conditions. On the basis of that, we can perform other timestamp based ordering protocol. We already discussed. These are the three conflicting pairs. Whenever any transaction Ti perform the read operation on a data item A, then we will check for the write operation, because for the read operation there is only one confliction pair, that is the write operation. But whenever transaction Ti perform any write operation on a data item, then we will check for the two parts, one for the read and another for the write, because for the write there is a two conditions, one for read and one for write. All these condition we will discuss here. These are the three timestamps as I already discussed. Now suppose if a transaction Ti issue the read operation here, if a transaction Ti perform a read operation, if the timestamp of transaction is less than the timestamp of write operation on X, then the operation is acted. Okay, but if this condition is false, but if this condition is false, we can perform the operation. Now if the transaction perform the write operation, we will check for this read and write individually. If the timestamp of this transaction is less than the read timestamp, then the operation rejected, and again we will also check for the write, then also rejected. Otherwise the operation performed. We will discuss with the help of example. Suppose we have three transactions, that is the T1, T2 and T3. This is the time of T1. T1 come at the time, this is suppose the 1 AM, 2 AM, 3 AM. T1 perform the read operation, after that T2, first T1, then T3, like this. Initially we take the read timestamp of A is 0, read timestamp of B is 0, C is 0, and the write timestamp for A, B, C is 0. Here the T1 transaction is the older one, because it come first, then T2 and T3, and T3 is the younger one. In this we can solve this problem with the help. Continue. Okay. We can solve this problem with the help of this example. Suppose if there is no rollback, it means that operation is executed. If this both the condition get false, if this condition get false, we can perform this operation, means operation is executed. If operation is executed, it means whatever the read timestamp of A, we get the maximum timestamp of A and the T. Suppose here the read timestamp of A is 0 and timestamp of this transaction is 100. Whatever the maximum values here is 100. Okay, now the new value of A, read timestamp is 100 here. If we reject this and we perform this operation, then we solve this that problem with the help of this. Now if in this process, if both the condition get rejected here and here, then we perform this operation with the help of this. In write operation, when no rollback, then whatever the new timestamp for the data item is what is the timestamp of the transaction. Like suppose in this the timestamp of T1 is less than, suppose the timestamp of T1 is less than the read timestamp of 3, that is 300. We can reject this because it is satisfied this. Now when we start from here, now let's take an example of this is 100 and read timestamp is 200. Again it satisfied, it rejected, and Ti is rollback. Otherwise, when both the condition get false, then we perform the operations, and the new timestamp is whatever the time of the transaction. Suppose here we perform the T2 transaction and the time of the T2 transaction is 200. Then the 200 is the new write timestamp of transaction. That transaction perform the write operation of any of the data item. These are the 2 points with the help of which of this point we can get the new read timestamp or we can get the new write timestamp. Thank you.